Today we'll talk about Chapter 17, International Trade. This is another one of those applications chapters where we take the theory and tools we've picked up earlier in the course and apply it to one area, in this case, international realm. So you've all heard the phrase globalization, right? And my guess is you have discussed that in a lot of your other classes, and probably many classes spend a great deal of time defining globalization. My definition of globalization, you won't find it in the book, but it's a simple one, and that's a gradual reduction in the costs of trade. And I've taken this definition from an economist named Daniel Spolber, who defines globalization this way, and then also defines the costs of trade, four costs of trade. There are the transportation costs. You know, clearly shipping something across the sea is getting cheaper all the time. And are you aware of a relatively new innovation that has dramatically lowered the cost of shipping? It's called containerization. And so if you go to a port like Oakland and watch the ships, you see that they're stacked with what look like semi-trailers. But these are shipping containers, and they can be easily taken off the ship and put on a truck. So that's relatively new innovation. It's lowered the cost of transportation. Another trade cost is a transaction cost. And that means it's more difficult. It's difficult to arrange a transaction, right? You have to find a buyer or a seller, maybe arrange a price with them, maybe you speak different languages. But certainly communication technologies and the fact that more and more people are speaking English and banking innovations have lowered these transaction costs. There are also time costs, in the sense that if you have your goods held up in shipping, well then you can't sell them, right? And if it's a perishable item like fruit, then maybe some of these items spoil. So not only is shipping getting cheaper, it's also getting faster. And then the fourth trade cost that Professor Spolber mentions is tariff and non-tariff costs. And that's one of the main focuses of this chapter. So tariffs are taxes on imports. And the United States and other countries have taxed imports for a long time, but those have been falling. And so we have a good explanation here for why globalization has been increasing. It's not that people didn't trade. You know, people have always traded throughout time, sometimes even very far distances. But lately it's been getting faster, and it's because all of these costs of trade are getting cheaper. So that's globalization. At least that's one definition of globalization. But right now what we'll do is go back to a model of trade that we looked at right at the beginning of the class. And this is using the production possibilities curves. And so we looked at production possibilities curves. We described how we can calculate opportunity cost by looking at one of these. And then we looked at how countries can, if they specialize in the production of the good in which they have a comparative advantage, and then trade, they can enjoy more consumption than they could if they didn't trade. So in other words, trade is a good thing. One reason is because of comparative advantage. So let me just remind you of some of the basics here. This is a production possibilities curve. We've looked at straight line ones that just had straight lines, and then also curved ones. And these curved ones are more realistic than the straight line ones. And what they exhibit is this property of increasing opportunity cost. So let's look at the opportunity cost. Let's say we're here producing 10 trucks and 0 boats. And then we want to produce 4 boats. So we move from here to here. Well, how many trucks did we give up? Just 1. So the opportunity cost of 4 boats is 1 truck. And sometimes we like to say, what's the opportunity cost of 1 boat? So if the opportunity cost of 4 boats is 1 truck divided by 4. The opportunity cost of 1 boat is 1/4 of a truck. But notice what happens to the opportunity cost as we move along. So now we want to produce, say, 4 more trucks. So we move from point C to this point below point B. So we get from 4 to 8. How many trucks do we have to give up? Now it looks like we have to give up about 3. So we're giving up more trucks now to get 4 more boats. So the opportunity cost is increasing as we move along here. And this makes sense because, initially when you were producing only trucks and you decided to produce a few more boats, you could take those resources. For example, those workers who weren't very good at producing trucks but are good at producing boats, you can take them out of truck production, put them into boat production. They'll produce a lot of boats and you're not going to lose many trucks. But when you're way down here and you take some workers, maybe you take the last workers out of truck production, put them into boat production, you don't add much to the boat production because they weren't good at producing boats, but you lose a lot of trucks because they were good at producing trucks. And so that's the reason for this shape. Lastly, any point on the production possibilities curve means you're utilizing all your resources. If you're within, like at point D, this is inefficient. You could produce more of both. You're not utilizing all your resources. Some people are just sitting around unemployed maybe. And then point E is unattainable. At least you can't produce at point E with your current resources. What we're going to show, however, is that you can achieve consumption at point E with trade. So you can't get there by yourself. You can't produce 9 boats and 9 trucks by yourself. But if you have a partner who has a comparative advantage and you have a comparative advantage of something else, then you can specialize trade and maybe you'll get there. So let's look and see how that happens. The one last thing I should mention has to do with calculating the opportunity cost. So, earlier I mentioned over here, we could go from 10 to 9 trucks, and then we would get 4 boats. But that changes, right? Because if you're here and then you get 1 more boat, it changes. So the opportunity cost changes at every point along here. So one way you can calculate what you might call the instantaneous opportunity cost. The opportunity cost at any single point is to take a line and place it tangent to that point. And then consider this as the slope of the curve and calculate the opportunity cost based on this. So basically the slope of this line, which is negative 0.5, means the opportunity cost of producing another boat is 0.5 trucks. Here, because the slope is steeper, right? It's negative 1. It means here the opportunity cost of producing another boat is 1 truck. And here it's even steeper, so it's 2. If you produce 1 more boat, then you're going to have to give up 2 trucks. So I don't want to go into too much detail on this. In some sense, it's not, it's accurate for small changes. But if you go, from here to here, right, you give up 10 boats and you go to 5 boats, then clearly this is not the opportunity cost, right? So it's good for small changes. So there's more I could say, but I don't want to confuse you anymore. That's basically the gist of it. So let's look at 2 countries now. On the left, we have a country with a little bit of a silly name called Roadway. And then on the right, we have a country called Seaside. And they each have different resources, different technologies, and these are embodied in the PPCs. At the moment, country A is producing at point A. That's 9 boats, 4 trucks. Country B, or rather Seaside, is producing 2 boats and 4 trucks. And so, based on the lines that are tangent at these points, we see that the opportunity cost of producing another boat in Seaside is 0.2 trucks. Remember, the opportunity cost is always in terms of the other good that you're giving up production of. In other words, it's pretty low. Whereas here, if Roadway is going to produce another boat, they're going to have to give up a lot of trucks. So the opportunity cost is higher. It's 2, right? So based on this, we ask ourselves, which country has a comparative advantage in producing boats? And you might remember, earlier we said, a country has a comparative advantage in something if their opportunity cost of producing it is lower. So basically you look at who has the lower opportunity cost. And so it should be easy for you to see that Seaside has a lower opportunity cost of producing boats. 0.2 versus 2. So clearly Seaside has a comparative advantage in producing boats. Now, it's impossible to have a comparative advantage in both things, as we saw before. So if Seaside has a comparative advantage in producing boats, that means Roadway has a comparative advantage in producing trucks. You could see this, by the way, if you just go in the other way and say, okay, now let's imagine how many boats we have to give up to get one more truck. You'll see that Seaside gives up a lot of boats, whereas Roadway doesn't give up that many. So Roadway has a comparative advantage in producing boats, because Roadway has a comparative advantage in producing trucks, rather, because they have a lower opportunity cost of producing trucks. Oh, there is a definition here about absolute advantage, a situation in which an economy or individual can produce more of any good per unit of labor than any other country or individual. And Roadway has the absolute advantage here. There are different ways, in fact, of thinking about absolute advantage. One way is just, if you use all your resources to produce trucks, how many can you produce? Well, here Roadway can produce 10. Seaside can only produce 5. So Roadway has an absolute advantage in producing trucks. Whereas if you use all your resources to produce boats, Roadway can produce 10. Seaside can produce 7. Roadway has a comparative advantage in boats. An absolute advantage in boats as well. So Roadway can produce both goods, can produce more of both goods, right? That's an absolute advantage. But we just saw it doesn't have a comparative advantage. And it turns out, for there to be gains from trade, what matters is that you trade with someone with a comparative advantage that's different than yours. This is a visualization of what we just said. So Roadway has a comparative advantage in the production of trucks because they only have to give up half a boat. But Seaside gives up 5 boats. And you can see this from the graph, but this is just a figure, some pictures to drive the point home. Terms of trade. Now let's say these countries start to trade with each other. The terms of trade is the rate at which a country can trade domestic products for imported products. So basically it's the price. Now, we don't know what the terms of trade are going to be. In this model, I mean, we have no way of, this model doesn't specify any precise terms of trade. But we know one thing. If Roadway is going to produce one more boat, they're right here at A. If they're going to produce one more boat, how many trucks do they have to give up? The answer is 2. Because that's their opportunity cost, by definition, right? So they have to give up 2 trucks. If they're going to buy boats from Seaside after they begin trading, what's the most they'll pay for a boat? 2 trucks. It would be silly for them to pay more, to offer Seaside more than 2 trucks, right? They would never do that. Because they can produce a boat themselves at a cost of 2 trucks. So why would they pay Seaside more than 2 trucks? So the terms of trade has to be less than 2 trucks for 1 boat, right? Now at the same time, what's the least that Seaside would accept?
In Seaside, if they produce a truck, they give up 5 boats. Roadway won't pay more than 2 boats for a truck, but Seaside won't accept less than 5 boats for a truck. So it looks like these countries won't trade, at least not if Roadway is exporting boats and Seaside is importing trucks. But what if they switch and Roadway exports trucks and imports boats, and Seaside imports trucks and exports boats? Will that work? If Roadway produces a truck, it has to give up 1/2 of a boat. Recall, the opportunity cost is just, in this case, the reciprocal. So for Roadway to produce a truck, it gives up 1/2 a boat. Therefore, Roadway won't accept less than 1/2 a boat for each truck it sells to Seaside. But for Seaside to produce a truck, it has to give up 5 boats. Again, that's the reciprocal of this number. So Seaside will gladly pay any price less than 5 boats for each truck it imports from Roadway. Roadway is willing to sell a truck as long as they get at least 1/2 a boat, and Seaside is willing to buy a truck as long as they pay less than 5 boats. In other words, any terms of trade between 1/2 and 5 will make both parties better off. So this is slightly complicated, but it makes a lot of sense. In short, the terms of trade has to be between each country's opportunity cost.
The final terms of trade will be somewhere between 1/2 boats for one truck and 5 boats for one truck in Seaside. Why? Because that's their opportunity cost. Now, how does the actual terms of trade, how is it actually determined? That's outside the model. You might think about this as a process of negotiation, where one country will say, well, look, I'm not going to pay more than 1/2 a boat. And the other country will say, look, I'm not going to give more than 5 boats. So it's going to be somewhere in the middle, right? Has to be greater than 1/2, but less than 5. And so for simplicity, let's just say it's 1. But depending on maybe relative bargaining strengths, it could be 2 or 3, right? But 1 will make it easier. Okay, so the terms of trade becomes 1. And if we take a line with a slope of 1, or -1 rather, and make it tangent to the PPCs, we see that each country will, first of all, change the amount of boats and trucks that they're producing. So in particular, roadway will move from point A to B. Because now that they can trade, it makes sense for them to produce fewer boats and more trucks. Likewise, Seaside will move from A prime to B. And so they're going to specialize. No, they don't completely specialize. They don't produce 0 trucks in Seaside. And in roadway, they don't produce 0 boats. So it's not a complete specialization like we saw before. So this is a more realistic model. And then after that, they figure out some exchange. So maybe 2 trucks for 2 boats. That would put them here. Or going this way, they give 2 boats and get 2 trucks. And that's what we see in this next figure. In roadway, starting out at point B, they're going to export 2.5 thousand trucks and import 2.5 thousand boats. And so notice, they're consuming at point C. And this point C is beyond their PPC, right? Their PPC is this line here. And so they're consuming this point C, which is to the right of the PPC. They would not be able to consume this point, this bundle of goods at this point without trade. And so this demonstrates the gains from trade based on comparative advantage. Likewise, this point C prime is outside their PPC.